Alright, so let us revisit the example from last lecture. So we have a Markov chain with two states, 1 and 2, and this Markov chain has a single recurrent class, right? And then also it's not periodic, right? Because we have self-transition of this type. So as a result, this is well defined, and this steady state probabilities from 1 to m, in that case for us m equals 2, right? So let us write this system and solve the system of linear equation for this example here. So what we have is pi 1 equals pi 1 times 0.5, right? Plus pi 2 times 0.2. So that's the first equation that corresponds to j equals 1. Now for j equals 2, pi 2 equals pi 1 times 0.5 plus pi 2 times 0.8. So we have a system of two equations with two unknowns, pi 1 and pi 2. Let's rewrite them. I'm going to pass this one on this side and this one on this side. So we get pi 1 times 1 minus 0.5, 0.5 equals pi 2 times 0.2. And this one, pi 2 times 1 minus 0.8 is 0.2 equals pi 1 times 0.5, right? We realize that these two happen to be the same. So they are not enough to define a unique solution. So we have to add another equations, and we know that these are probabilities. So pi 1 plus pi 2 have to be 1. And so now we're going to keep one of these two. Let's say this one. I'm going to write it here. And we can rewrite it by saying that pi 1 times 1 over 2 equals pi 2 times 1 over 5. Right? So now we're going to take that, replace pi 1 equals 2/5 of pi 2. This is the result of that. And we're going to use that pi 1 and replace it here. So we end up pi 2 times 2/5 plus 1 equals 1, which means that from here we get that pi 2 equals 5 plus 2, 7, so 5 over 7. And then we use that, replace it here, and we end up having pi 1 equals 2/5 times 5, 7 equals 2, 7, and we check 5 plus 2 equals 7, so these are real probabilities. So the probability that you find yourself at state 1 at time 1 trillion will be approximately 2 over 7. The probability that you find yourself at state 1 at time 2 trillions is again approximately 2 over 7. So essentially what we have here is the probability of being in that state 1 settles in a steady value. That's what the steady state convergence means. It's convergence of probabilities, not convergence of the process itself. Again, the process will keep jumping back and forth, but the steady state probability will settle to a given value here in 1. That will be 2 over 7, and the steady state probability in being in 2 will settle to 5 over 7. And finally, in this example, and more generally when we have a single class and no periodicity, the initial state does not matter.